Hello, and in this video we're going to be talking about modeling with series in the Edexcel A-Level Maths course. This is, if you want to use Pearson's book, this is chapter 3 of the Pearson. And modeling actually is when you use the concept you learned in the series chapter, all the formulas, into real life questions. So guys, this is a question from June 2006, question 6. This is from OCR, by the way, and I would like you to read this question now. And what I want to do in this is a tutorial. I'm not going to do everything of the question. I'll just get you started and you finish it yourself, and obviously you can check the answers later on over there. Okay guys, I'll give you a couple of seconds, couple of minutes, pausing and read the question. So once you've done, the first thing which you need to know is identify which type of series is this. What I mean by that is it the arithmetic series, if you look at my first video, or it is a geometric series or sequence, whatever it is. Okay, so let's read. John aims to pay a certain amount of money each month into a pension fund. He plans to pay £100 in the first month. So I will always start the first, then 100. This is the number of terms on the top in circle. And second, increase the amount paid by £5. So guys, this information should be enough for you to identify that this is an arithmetic series. Okay, so 110 in the third month and so on. Okay, so now answer A and B. How much will he pay in the final month, which is 240th? So you're going to find U 240, the term, because this is that particular term they want. And how much will he pay all together over the whole period? This is the sum of 240. I'm not doing this work for you, just work it out yourself. Then Rachel also plans to pay money monthly into pension fund over a period of 240 months. So she also wants to pay it for 240 months, starting with £100. So Rachel's first investment is £100 as well. And then her monthly payments will form a geometric series. So I don't know what this progression is. So second one will be 100 times R, AR. Then the third one will be 100 times R squared. And she'll pay 1500 in the final month. So guys, this is the amount she pays in the final month. That means this is U 240 in geometric series is 1500. So we're going to use the formula of a geometric series this time, which is UN equals AR n to the power minus 1, and that is equal to 1500, and we will solve it to find the value. And n is, we know what n is, n equals 240, and we're going to solve to find the value of R because we know A as well. Okay, work that out. And once you found that R, people, then in this question, they've asked you to calculate how much money Rachel will pay all together over the whole period. This is S240 for the geometric series is what you have to find. So I would expect you to finish this question yourself and check the answer if you have to for OCR. You're going to go in PM Physics and Maths Tutor and you can check the answer from there if they are. Otherwise, go into OCR website. All right, guys, we move on to second question. This is also I've taken from OCR. There's a reason, guys, I'm mixing these questions up because Edexcel questions you got to try yourself. Those who are doing Edexcel. Otherwise, we want to see what's happening in the different boards as well. This is June 2005, question 8. The amount of oil pumped from an oil well in each of the years 2001 to 2004 formed the geometric series. They've given the geometric progression with the common ratio of 0.9. They're giving you R. So it's better to identify, it's better to annotate the question that's an R. Okay, and 2001 to the amount pumped in 2001 was this much. That is the first term, so that will be A. Calculate the amount pumped in 2004. Should be straightforward. 2001 is the first term, then 2, then 3, then 4. You're going to find the fourth term of the series, which will be AR3, and that is what we have to find. We know what A is and we know what R is. We can find that out. Okay, no problems. Right, then the next part, the information is it is assumed that amount of the oil pumped in future years will continue to follow same geometric progression. So same series, same A, same R. Production will from the well will stop at the end of the first year, at the end of the first year in which the amount pumped is less than 500 barrels. That means the moment UN, that particular term, becomes less than 5,000, the production will stop. So you want to find N when this happens, then count from 2001 which year will that be? If n comes out as 10, that means at the end of 10th year, that means at the end of 2010, this production will stop. So guys, work that out yourself. This is again a very simple application of formulas. If you can't do it, we can work together later. Right, and the third part of the question is the same again. Once you've found that year or number of years, or n, you're going to find the total amount of oil pumped. You're going to find Sn up to that point. Straightforward. Okay, application of formulas. If you cannot do it, you can come back to me and I will explain that to you later. Okay guys, we move on to the next question. All right, question number 3 I picked from Solomon worksheets. This is again, you can get this on Physics and Maths Tutor, worksheet D, question number 13 from C1. And C1 in older times used to have only arithmetic, so you know this is going to be arithmetic. But let's check, how do we identify this from the statement? Tom's parents decide to pay him an allowance each month beginning on his 12th birthday. So when he's 12, it starts. Okay, so 12th birthday, his first term. The allowance to be £40 for each of the first 3 months and 42 for each of the next 3 months, and so on, increasing by £2 per month after each 3-month period. So that means what, guys? First month, second month, third month, this is 40, 40, 40, then fourth, then fifth and sixth, going to be 42, 42, 42, then seventh, then eighth and ninth, this will be 44, 44, 44. Really important to identify how your sequence or series is progressing. Okay, find the total amount Tom will receive in allowance before his 14th birthday. That means he's going to get paid for this year, 12th year, and then he's going to get for 13th years. That means he's going to get paid for 2 years altogether, and find the total amount he gets paid. Okay, I'm not going to do that for you. This is a 4 marker. Then we'll check part B. Try that yourself, otherwise I'll come back to you. Show that the total amount in pounds Tom will receive in allowances in the n years after 12th birthday, where n is a positive integer is given by. This is a good one actually now, people. This is a really good one. Because this series does not make a part of geometric or arithmetic series. But listen, if you combine this is a hint I'm giving to you. And if you take 3 months period as one period, so he gets 120 in the first period, then he gets 126 in the second period, then he gets 132 in the third period, and so on and so forth. Okay, so right, this is a period of 3 months. So this becomes an arithmetic series. Okay, and you're going to find the nth term, n years. So n years actually will have how many 3 months periods? We'll have 4 times n 3 months periods. Does that make sense, people? This is really important that you make n years total. 1 year means there are 1, 2, 3, 4 3 months periods. There will be 4. 4 of these terms will come in 1 year. The next 4 will come in second year. So 4 times n 3 months periods. So guys, we're going to find, it says total amount, we're going to find S of 4n using this arithmetic series formula. Okay, once again, you're going to find S of 4n using the arithmetic series formula, and that's what we're looking for. Once again, I tell you why is that. Because they do not make a part of any arithmetic series, but once you combine the 3 months period, becomes part of, this is an arithmetic series. But now we're going to figure out that how much money would you get in n years total. N years means these are not the years. This is not first year, second year, third. This is the first quarter, second quarter, third quarter, and so on. So how many quarters are there in n years is 4n. Okay, so work that out. We work out S of 4n to get the final answer. Thank you. Move on to next question. Alright guys, the next question which I've copied from here is, this is from Physics and Maths Tutor again. C2 questions by topic, and this is question number 7. Okay, let's read this through. A trading company makes a profit of 50,000 in year 2000. That's 2006. So this is year 1. So 2006 is my year 1, and it is 50,000 profit. Okay, model for future trading predicts that profit will increase year by geometric sequence. Common ratio R is greater than 1. Okay, so it's clear, it's identified as geometric. The model therefore predicts in 2007 a profit of 50,000 R. Obviously, we know that. Second term is AR, so 50,000 R. Okay, Write down an expression for predicted profit n is, that means you're going to find un, guys. So part A, you're going to work out un. You know what A is? R will stay as R, okay? Then the model predicts that in year n, the profit will exceed by 200,000. Once again, people, same thing. So UN is increasing by 200,000, and you use logs to bring that out. So what do we do in here, guys? This will be 50,000. Let me just help you with this. Times R to the power n minus 1 is greater than 200,000. Okay, so we work out taking logs to both sides. Work out, and okay, if you take logs to both sides, I call it TLBS, right? So this becomes, first of all, we divide by 50,000 anyway before we take by logs. This is R to the power n minus 1 is greater than 4. So TLBS, this gives n minus R log R is greater than log 4, and you take 1 to the other, divide that, then take 1 to the other side, you'll get that expression which you want. Okay, so we move on to the next part of the question now. Right, the next part says, using the model with R equals 1.09, so given me R there, find the year in which profit will first exceed 200,000. Lovely, so you're going to find, I'll use R equals 1.09 and see what the value of n is, okay? So figure that out. N has to be greater than something. If n is 10, if n is greater than 10, that means 2010 add 10 is 6 into it will be 2017. Work it out. Let's see what do you get from this, guys. We move on to the next question then. Alright, guys, so this is also a question I've taken from Physics and Maths Tutor, and this is C2's questions by topic. Question number 12. The cost of Brian's new car is P. He accepted an interest-free loan of P, which is agreed to repay by monthly installments. The first installment is 120. The installments was increased by £5 per month. So this is 120, then 125. Second and third installment, this and this. That's the arithmetic series. Okay. Given that loan was repaid in n installments, and the final installment was 325, show that n equals 42. Guys, many ways of working this question out. Okay, you're going to find, you know your A, you know your D, you know your final term. So and so UN would be equal to 325, and find n. Okay, find the value of P. P is the A actually, so Sn, whatever you find, and S42 in that case, for that matter, will be equal to the total loan, which is P. Okay, so work out the value of P from there, because that's S42. Reason being, he took the loan of interest-free on interest-free basis. That means it doesn't pay anything extra. So all total money he pays in 42 months is equal to the amount the car priced for. Okay, now the value of Brian's car at the end of the first year was 7,200. At the end of the first year is 7,200. And what we have to find in this, and sorry, what happens after that, it depreciates every month by 2%. That means it goes down every month by 2%. And knowing your percentage knowledge, you're going to be having 7,200 as your first term, then 7,200 times 0.98, and 7,200 times 0.98 squared, and so on and so forth. At the end of the first year, value of the car is this, and we're going to find the price of the car at the end of the third year. That means there are 24 months or terms of this series. We're going to find the value of the car at the end of the third year. That means we're looking for U24, where this is A and this is R. So work that answer out. U24 is what you're looking for. Okay, so at the end of third year, 24 terms, and A is given to me, R is given to me. You can work that out. Alright, guys, so there are a lot of questions in the last exercise of the book as well, if you want to go through that, and otherwise just finish these questions and we talk about it later. Thank you. Be very careful. One more thing I want to tell you: in geometric series, some calculations you're involved in dividing by log terms. In inequalities questions especially, really important, people, that log of anything less than 1 is a negative term. So be very, very careful. whenever you divide by log of anything less than 1, the inequality will reverse. For example, let's say n log 0.7 is greater than log 3. So if I want to divide both sides by log 0.7, I get n is less than log 3 over log 0.7. Okay, because log 0.7 you know is a negative term. Check the graph of log, guys. Log of 1 is 0, and anything of, if you want to find log of anything less than 1, that is all negative terms. Okay, with that we've finished the chapter of series. Hope you've learned it, practice more, and we get better at it. Thank you very much. See you soon.